Section 10.2, we looked a little bit at parametric equations. Section 10.3, we're going to look at parametric equations and do some calculus. What kind of calculus do? We do derivatives and we do integrals. That's right. So assume x equals f of t and y equals g of t is a smooth function. Anybody know what a smooth function is?
Function with no holes.
Probably. No, they could have holes in them. A cusp? No, actually, those aren't what we call smooth. What we call smooth is smooth means f prime at t and g prime at t are not both 0 for any value of t. That's what we call smooth, and it'll make more sense here in just a second. Why do we want them to both not be 0? All right, so then dy dx, the derivative, the normal old derivative that we always work with, is g prime of t over f prime of t. So why would it be important to me that both g prime and f prime are not both 0?
You don't have 0 over 0.
Why do I not want 0 over 0?
Undefined.
Not only is it undefined, it's also indeterminate. Right? What if I have 5 over 0? What's 5 over 0? It's undefined, but it also tells me you have a vertical asymptote there. That's correct. 0 over 0 can be anything. That's one of our indeterminate forms. 5 over 0 is not an indeterminate form. So if you had 5 over 0, your derivative would be undefined, which is telling you you do have some sort of cusp there. So a function could have a cusp. Now, this makes more sense even if you write it this way. G prime of t is dy dt, and f prime of t is dx dt. So why does it make sense that that should be equal to dy dx? Look and multiply, and that's what you get. And that's not technically a proof. If you want to read the proof of why this works, it's in your book. It's not really important as far as I'm concerned for this course. All right, so I might give you some parametric equations. X equals, somebody give me a nice function with a letter t in it.
T minus 3.
T minus 3. And y is, somebody else give me another nice function with some t's in it. Not the same thing, you want to have a little different. How about t squared plus 5t minus 8? I might ask you, determine the equation of the tangent line at x equals, anybody got an x number that they like a lot? 2. At x equals 2. What do I need to know in order to find the equation of the tangent line? I need to know the slope, so I need to know dy dx. So dy dx, according to the rule we just had, we take the derivative of the y thing, that's 2t plus 5, divided by, I take the derivative of the x thing, that's 1. But I need a number. To get the slope, I need to have a value for t to plug in and just get a number.
When x is 2, t is 5.
When x is 2, t equals 5. How did you determine that?
I plug 2
I plugged 2 in right there, and I added 3 to both sides. I got 5. So my slope is going to be the derivative evaluated at t equals 5. So I plug 5 in, I get 15. Alright, now I use my favorite little formula here. Y minus y1 equals m times x minus x1. Y minus, what's my y1 number? I don't know, I'll come back to it. Equals m. M we figured out that was 15 times x minus 2. What's my y1 number?
You plug the t equals 5 into the y equation.
When x equals 2, I know t is 5, so I'm going to take 5 and plug it into the y formula, and that's going to give me my y number. Let's see, that's going to be 25 plus 25 minus 8. That's 42. Questions on that? Okay. How about x equals the square root of t, y equals 3t minus 1, and t equals 1. And I want to know two things. I want to know the slope at t equals 1 and the concavity at t equals 1. How do I find the slope?
First derivative.
First derivative. So dy dx is going to be, how do I find the derivative again in parametric form?
Derivative of y over derivative of x.
Derivative of y divided by derivative of x. What's the derivative of y? 3. What's the derivative of x?
1/2 t.
So my slope is going to be, I plug in 1, that's 3 over 1/2, that's 6. And I'm going to rewrite this as, I don't know, how would you rewrite that? Six t to the 1/2. How did I get 6t to the 1/2? I took the 1/2 and I flipped it. That gave me 3 times 2, which is 6. Since this has a negative exponent and it's on the bottom, it comes to the top. And when it comes to the top, the exponent becomes positive. Okay, how do I find the concavity?
Second derivative.
I find the second derivative. What's the second derivative? Three t to the negative 1/2. That's partially correct. Here's the issue. I want to know the derivative with respect to x. If I call this function here, I'm going to call it z. And what I want to know is I want to know the derivative of that function with respect to x. What you just gave me, you took the derivative of this thing, that would be dz dt, wouldn't it? Because you took the derivative with t being the variable.
So could you say that t equals x squared?
Nope, I can't say t equals x squared. I'm going to have to divide by something. If I want dz dx, and I have dz dt, what do I need to divide by? Dx dt. Just like we did to find the first derivative. To find the first derivative, we took dy dt over dx dt. To find the second derivative, you take the derivative, and then you still have to divide by dx dt. So we have to divide by 1/2 t to the negative 1/2. Which is 6. So what does that tell you about the concavity at t equals 1? Positive. So the function is concave up. Plug in 1 for t, but there aren't any t's left. So it truly wouldn't matter which number I'm using for t. Any number for t would give me a positive value, would give me 6. This graph is always concave up. Why is this graph always concave up?
It's just a number.
True. If I were to draw this function, what would I have?
What are we drawing? Which one?
This function. True. The x is not. What's it look like? Parabola? Why a parabola? Because nobody else said anything. Okay. If it's a parabola, it must be a parabola opening up because it's always concave up. Why is it a parabola? Get the t all by itself. T is x squared, and then take that and plug it into there. You would have y equals 3x squared minus 1. What kind of graph is y equals 3x squared minus 1? It's a parabola. It opens up, and so it is indeed always concave up. Questions on that? All right, so that's derivatives. Derivatives pretty easy. Integrals. Back in Calc 1, we have formula for arc length. Has an integral in it. Anybody else remember anything else about the formula for arc length? The formula for arc length was the integral from x0 to x1 square root 1 plus the derivative squared dx. All right. So again, let's say we have our function in parametric form. I don't want to use f because I already used f there. So I'll use g of t and h of t, I suppose. And we're going from some domain, 0 less than or equal to t, less than or equal to b. All right, well, this would be the integral from x0 to x1 of the square root of 1 plus dy dx squared dx. Correct? That's the integral from x0 to x1 of the square root of 1 plus dy dt over dx dt squared dx. What did I do there? What's dy dt over dx dt? That was our definition of dy dx just a minute ago. So I took this dy dx and I replaced it with this derivative in parametric form. All right. So this is the integral x0 to x1 of the square root of dx dt over dx dt squared plus dy dt over dx dt squared dx. What did I do that time? Yeah, this is the number 1, isn't it? dx dt over dx dt is the number 1. 1 squared is 1. So I took the number 1 right there and I wrote it in a funny way. Why did I do that? Because now what can you tell me about these two fractions? They have a common denominator, so I can add them together, can't I? So this is the integral from x0 to x1 of dx dt squared plus dy dt squared, all divided by dx dt squared, and then I got the square root of that whole stuff, dx. So they had a common denominator, I added them together. This is now the integral from x0 to x1 of the square root of dx dt squared plus dy dt squared divided by dx dt, and then I still got dx there. What did I do on that step? I took the square root of the bottom because the bottom had a square. So on the bottom, the square root and the square simply cancel each other out. Final answer. This is the integral from a to b of the square root of dx dt squared plus dy dt squared dt. First off, where did I get dt? I took this dx dt on bottom, I flipped and multiplied, that made dx. How come my x0 and my x1 changed to be a and b? Because they're both just terms. And what this means is if I take a and plug it in, I get the x0 number. And if I take b and plug it in for t, I get the x1 number. So this is the equation for arc length when you're in parametric form. It comes directly from the formula for arc length that we developed in Calc 1. All right, so let's pick a problem out of the book here. X equals 6t squared. Y equals 2t cubed, that says. And our interval is from 1 to 4. And it would help if you could see what I'm writing. There we go. The directions are find the arc length. Our answer would be the arc length is the integral from 1 to 4 of the square root of, I take the derivative of this one. What's the derivative of 6t squared? 12t, but then I have to square it. So it's going to be 12t, whole thing squared. Plus, I take the derivative of this one. What's the derivative of 2t cubed? 6t squared. Square that, dt. So that's the integral from 1 to 4 of the square root of 144t squared plus 36t to the 4th dt. How do you integrate that? In fact, I can factor out a 36t squared, I think. So that's going to be the integral from 1 to 4 of, when I factor out a 36t squared, I can then take its square root. What's the square root of 36t squared? 6t times the square root of, what's 144 divided by 6? Or, yeah, 144 divided by 36. 4. So that's going to be 4 plus t squared dt, I think. All right. Now what? It becomes a u sub problem. U equals 4 plus t squared. Du is 2t dt. Integral 3 square root of u du. Where'd the 3 come from? I need a 2 from this. So 2 times 3 gives me 6. So I take this 6, I divide it by 2. For this, that gives me the 3. Square root of u du. And then my numbers would change. That would be 4 plus 1, that's 5. And that would be 4 plus 16, that's 20. I integrate. That's 3 times u to the 3 halves. I said 3 halves and wrote 3 thirds. And then I would have to multiply by 2 thirds. Evaluate at 5 and 20. Final answer looks like 2 times 20 to the 3 halves minus 2 times 5 to the 3 halves. Questions on that? All right, the last thing in this section, surface area. In Calc 1, we had a formula for surface area. It had an integral in it. And it depended if we wanted to spin around the x-axis or if we wanted to spin around the y-axis. Anybody remember the formula for surface area? It had an integral. It had a 2 pi. If we want to spin around the y-axis, it has an x. Square root of 1 plus the derivative squared dx. Basically, we're taking the arc length, the square root thing was our arc length, and we're multiplying it by 2 pi x. Why would we multiply by 2 pi x?
That's one full rotation is 2 pi.
Your radius is x. You spin around, your circumference is 2 pi r. So this is 2 pi times your circumference times your arc length. So think of a teeny tiny little cylinder. Its surface area would be 2 pi times the radius times the arc length. What was the difference if I wanted to spin around the x-axis?
Just pi.
Not pi. Just one thing changes though. What would my radius be if I want to spin around the y-axis? I'm sorry, if I want to spin around the x-axis, it would be my y. It would be y. So it became 2 pi y square root of 1 plus the derivative squared dx. So in parametric form, that's going to be 2 pi integral x at t, whatever that function x is, square root of dx dt squared plus dy dt squared dt. Or it'll be 2 pi, the integral, whatever the function for y of t is, square root of dx dt squared plus dy dt squared dt.
So we need 2 formulas that are related for t.
Correct. So a typical problem is going to look like, looking for one in the book here. X equals 1/4 t squared. Y equals t plus 3. And we're going from 0 to 3. And which axis do you want to spin around? I'll pick one. Let's go the y-axis. So your answer would be the surface area is 2 pi, the integral from 0 to 3 of x of t. X of t is 1/4 t squared times the square root of, I take the derivative. What's the derivative of 1/4 t squared? 1/2 t, but then you have to square it. You're back to 1/4 t squared. Plus, I take the derivative of t plus 3. 1 squared is 1 dt. How would you evaluate that integral? There's 2 ways. The easy way and the hard way. What's that? I was thinking I would use my calculator, but same idea. That's the easy way. The easy way would be I would use my calculator and have my calculator approximate it. Of course, you could use Wolfram Alpha. What would be the hard way? By calculus. And what kind of fancy calculus would you have to do?
Is this a trig sub?
This is a trig sub problem. What tells you it's a trig sub problem?
Square root of a t squared plus 1.
You have a square root and a square. That's a trig sub problem. That would be the hard way. When you go to take your final, the directions will be set up the integral, and then it will say you may use your calculator to evaluate that integral.
Oh, thank you.
There will be other parts of the test where I test your ability to do trig substitution. But for that specific problem, I would say set up the integral, and then I would say you may use your calculator to evaluate.
Where is that in the calculator?
Where is that on the calculator? Go to Math go down, 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 down. There's your function integral. Now, it's going to be kind of a pain in the neck to type it in. You're going to need 2 pi times 1/4 t squared. My calculator happens to be in parametric mode, so it's giving me the t when I push the xt button, times the square root of 1/4 t squared plus 1, comma, t is my variable, comma, start at 0, end at 3. This is much, much nicer, by the way, if you have the new operating system.
Yes, it says it up.
You got the new operating system on yours?
Yeah.
Let me see yours for a second then, please. If you have the new operating system, when you push that Math1620, it looks like that. It looks much, much prettier. So you would 0 to 3, you just use your arrow buttons to move between the spaces. This part's still kind of a pain, 2 pi times 1/4.
Isn't it 2 pi on the outside of the interval?
Does it matter?
Yeah, so
It's a constant. Constants can float in and out wherever you want them. Square root of 1/4 t squared plus 1 dt. So if you do have the new operating system,
You did
didn't do
0.5 t squared, not 0.25 t squared. I took 2 pi.
right there,
Yes.
yeah. So I did it wrong on mine. Still did it wrong. You do get the same answer, but it looks a lot prettier if you have the new operating system. Questions on that?